Greetings viewers, Eric the Car Guy here, back again with another video from my Basics series. This is a series of videos that I'm doing that cover general auto repair topics as opposed to step-by-step repairs. For today's video, we are going to talk about using Plastigauge. And Plastigauge is, for lack of a better word, a measuring tool. It is used to measure clearances between things, and specifically today we're going to measure connecting rod bearing clearances with Plastigauge. Now I will say that Plastigauge is not a replacement for precision measuring tools, but it's a heck of a lot better than nothing at all. And it's a nice final check, even if you have done your measurements with micrometers and such, because let's face it, when you're putting together lots of small parts in an engine, it's sometimes easy to get things mixed up, and the way to make sure that you have the right thing in the right place is to double check. Measure twice and cut once, as they say. But for today's video, we're going to go over the use of this Plastigauge, and we're going to talk a little bit about it and the different things that you can do with it. So why don't we get started? Got an engine block sitting here. Let's measure some connecting rod clearances, shall we? As I mentioned in the intro, these are precision measuring tools. This right here is a bore gauge. And basically what it does is it measures holes. So normally you would be using something of this type in order to measure basically the inside diameter of things. You put different sized tools on the end of this, and it basically gives you an accurate measuring of the inside of a bore. And here I have a set of calipers. These are precision measuring tools that measure the outside diameter of things. In this case, we would measure the connecting rod itself to find out how big it is. We would take that measurement, the measurement of the inside of the bore on the big end of the connecting rod. We would also measure the thickness of the bearing and add all of those up and subtract our clearance from that. So that's how you would do it in a precision way. Plastigauge eliminates the need for all that. You'll note that on one side of the Plastigauge we have measurements in increments of inches. On the other side it is measured in millimeters. So you don't want to get those two things confused when you do your measurements. I'll show you basically how to do that. But one other thing to note here, this I have is the green Plastigauge, and the green Plastigauge measures between 0.001 to 0.003, so 1 to 3 thousandths of an inch is what these measure. Now if you use the red, that would be 0.002 to 0.006, so these are the ranges that you could go for. The blue, 0.004 to 0.009, the yellow, 0.009 to 0.020. Those are all the different sizes of Plastigauge, and you have to make sure that you get your correct size Plastigauge. Now what I've done here, we are working on a 5.3 liter engine block for the connecting rod. So what I've done is I've looked up the clearance specs for that, and when it was produced, when it's brand new, the clearances between the bearings is 0.015 to 0.063 millimeters, or 0.006 to 0.00248 inches. So that's what it's like when it's brand new. The service limits are 0.015 to 0.076 millimeters, and in inches from 0.0006 to 0.003 inches. So those are the service limits. Now that, some of you have probably already figured out, is right at the top of our range of this Plastigauge, which is okay because that is the service limit. So I'm okay with using the green on this because, as I said, that's right near the limit. So it does fit within this range. So you want to make sure that you, first of all, to choose the right Plastigauge. One other thing that I'll mention is you should really use this at room temperature, like 65, 70 degrees. I will admit that it's probably closer to the 50s and 40s in here, so it's probably not going to give us an accurate reading. However, it will give us the ability to show the process of how to do this. Let's go over to the engine and we'll demonstrate how to use a Plastigauge. Here we have our Chevrolet 5.3 liter engine block. And these are the connecting rods here. Now I'm not going to, you can do the mains in the same way. I'm not going to do the main bearing clearances in this video. I'm just going to do these connecting rod bearings, mainly because they're so easy to access. I mean, they're right here on the top. Okay, I'm going to start by removing this cap here. Something I want you to note, like right off, this is the outer edge of the bearing cap itself, but I want you to take a close look here. You see how that's not a flush, flat surface? What that means is this is a cracked or broken connecting rod. I'm sure there's other terms for it, but the reason they do this is they forge the connecting rod is all one piece. So this is all one hole right in here, and it's bolted together. Well, it's not even bolted together, it's just cast as all one part. Then after it's cast, it's put inside of a special tool, and this is broken off of the outside of the connecting rod. And they do this because basically it makes for a stronger connecting rod to do things this way. Many connecting rods you'll see machined with a flat surface here. Those are perfectly fine and dandy. However, as I said, this basically makes for a stronger connecting rod. The reason why I mention it, and the reason why it's so important, is because if you don't put it back together in the same way it came apart, these will not mate up correctly. So you want to make sure that if you have this type of connecting rod, so if you see this rough surface and it looks broken, it is broken, but it's supposed to be that way, so don't freak out. Here's our bearing. It's held on here with a little bit of oil. Actually, that bearing doesn't look too bad. It looks like it's got some normal wear. You can see around the outside it's worn a little more. To measure the clearance here, here's the journal on the crankshaft. First thing we want to do is clean everything up. So I'm going to wipe off any excess oil that's on this bearing. I want to try to make it as clean as possible. And you want to do this with new bearings also. So you want to make sure that your new bearings have the proper clearance, because as I've said in other videos, your oil pressure is determined by the clearance right here. So if this clearance is too excessive, your oil pressure will drop. In fact, that's many times why you get a flickering oil light. However, if this clearance is too tight, there won't be enough oil that will be able to access this area, and as a result, you'll get too much friction and it'll burn it up in short order. Also, other connecting rods, you want to make sure you get them on correctly. Many times they'll be numbered, stamped on the outside, something of that nature to tell you where their location is supposed to be. Make sure you follow that, because these things are machined into pretty much where they live. I'm also going to wipe off the excess oil inside of this part of the cap as well. Alright, now that we're sure that we have a clean surface, remember things need to be at room temperature also. I'm going to try to get the plastic gauge out of here. Maybe it'll just slide out the end for me and be really nice. There we go. Just going to open it up a little bit. Nope. Have a piece fall right out the back. Of course, I'm working on one side and it falls out the other. Yay. Okay, so here's the actual business itself. This is the plastic gauge. So you want to try to basically figure out how wide a piece you need. You can just sort of break it off there. It's very simple. I'm just going to insert this back into here. I want to make sure that I get my bearing on correctly. So these little tabs go on opposite ends. I can see this tab for the other top half of the bearing there. So I'm going to basically put the plastic gauge in place just like that. So the plastic gauge is laid across the journal, like so. As I said, the bearing goes on like this. Make sure everything's clean, and try not to roll it around. Try when you put the bearing on just to put it on there and just nail it and get it flat. There we go. Okay, I remember my numbers being on this side, and I'm just going to install the bearing cap. We'll run these down. Now this is a critical step. I can't just finger tighten these. You have to torque the item to spec. And according to the specs that I looked up, we need to torque these down to 15 foot-pounds, and then we need to, or 20 newton meters, and then we need to go another 85 degrees. So you're going to get a little extra bonus here and see how to torque things with degrees. So we'll start out, we'll do it at 15 foot-pounds. Set my torque wrench. So we'll set these to 15. Now you do not want to rotate the crankshaft when you do this. You want to make sure that it stays still. Okay? Now that we've gotten that part of our measurement, I have a degree tool here, and it's set up to get the different degrees. So the first thing we do is we basically want to set up our 0, find a place to lock the tool off somehow. Sometimes easier said than done. This will work. That'll do, donkey. That'll do. Got it settled down there. And get it to where we'll lock it down, 0 it out, 0 on the gauge. I do this with a breaker bar. Okay, got a little bit of tension. Going to set this up on 0. Lock this down. And I'm going to bring this around to 85 degrees. 85 degrees, it looks like this is broken up. There's 60, so in between that should be 70. The next one after that is 80. So about halfway in between towards 90 should be 85. I'm going to try to hold this in place. Turn this until I see 85. There it is. You can see on there, I've got the dial down to 85. I'm going to do the same thing on the other one. Doesn't matter where you start or set this thing as long as you 0 it up. And I'm going to keep rotating until the line comes around to halfway between the 90 and the mark next to it for 85. That looks good right there. Now that we've torqued it down, we can take everything apart and check our clearance. So that I don't draw the ire of some viewers, I'm going to undo this via breaker bar rather than using my impact this time. Carefully remove the bearing, and voila, there's our plastic gauge. Not only does it leave an impression on the journal, but it also leaves an impression on the bearing. And that's what we're after. We're after that squish or that crush. Basically the rule with plastic gauge is, that the thicker it is, the smaller the clearance. The thinner it is, the larger the clearance. So it looks like we've got some pretty decent clearance here. I'm going to check it here on the journal, since it's the easiest to show you, I think. Now I'm going to cut off a small section of this. All you really need is one grouping. So each one of these is a grouping that you see here, and all you need to do your measurement is just one of those. As I said earlier, make sure that you know what side that you're on. This side is millimeters and this side is in inches, so make sure you know what side you're on. So these are just basically conversions. The thicknesses of all these are the same, however the measurements are going to be a little bit different. Now that we have that, we just basically line that up with the paper there. It's definitely more than 0.003, definitely more than 0.002. Honestly, it looks closer to 0.0015. That looks dead on. You see how it's bracketed in between there? That is our just general measurement. And that's all plastic gauge does, is it gives you a general measurement. It's not going to give you 100% accurate, but it's going to get you, I suppose, close enough. For engine building and blueprinting, you measure every single journal in several different places to make sure it's not out of round, that type of thing. But this, for assembly purposes, making sure that something is correct, this is how you use Plastigauge. So looks like this clearance right here is going to fall within the 0.0015 or 15 thousandths range. Guess what? We're bang within our limits. Also, this is what it's said to be new. So actually, this connecting rod, this journal is in really good shape according to the Plastigauge. So good information. I'm going to put links in the description to where I found this information on this engine, as well as the torque specs, so that you can go there. Also to these tools, all the tools and Plastigauge, everything that I've shown in this video, there will be links in the description, so check there if you have questions. And that's how we measure stuff with Plastigauge. Is it accurate? Well, it's accurate enough. As I said, this might be something you do in assembly, but if you truly want to know what's happening as far as those clearances and things go, you need those precision measuring tools. But Plastigauge is a heck of a lot better than not doing anything and just throwing something together. So if you find yourself needing to put an engine together and you don't have precision measuring tools, Plastigauge can save your butt. It can put you in the ballpark, and in some cases the ballpark might be good enough. This is how you go about it. As you can see, it's not that difficult. You just need to make sure that you know the torque specs and you follow the procedure correctly. Also, one last thing to note, if you take a look at the actual gauge after it's been on there and actually crushed, take a look at the thickness to see if it's uniform. If it's thinner on one side and thicker on the other side, that's something to be aware of, because metal parts might not necessarily be perfectly in line, and down here in the bottom end of the engine, it's pretty important that they are. So that could be an indication of an issue. So if you find that, you might want to measure it again and check to see if you have that a second time. You can just, if you want to measure a second time, you can just clean off the old material and add new, and you're just fine. This does not damage anything. It's really just wax is all it is. So it's not going to hurt anything, even if you forget and leave it on there. So it's really nice. It's a simple to use, easy tool, and it works, to be perfectly honest. As I said, links in the description to all the important stuff. So I'm going to wrap this up. Hey, if you have automotive questions, head over to ericthecarguy.com. Why? Because it's the coolest place on the planet. Well, aside from that, there's a welcome video there to tell you about all the amazing features we have at ericthecarguy.com to help you solve said automotive issues. If you wish to connect with Eric the Car Guy socially, we can do that on Google+, Facebook, and Twitter. Links in the description. And I close each of my videos with be safe, have fun, and of course, stay dirty. Measure twice, cut once. See you later.